Hello, and tonight we have another soldering video, because to be honest I've had this lying around for a couple of weeks already, and sometimes I think the soldering is just a very meditative occupation, and I will do more Let's Code videos in the future and other stuff, but they actually take quite a bit of work. And this here is something that you can just do in one evening without having to think too much. So what do we have here? We have a very cheap radio kit from Amazon. Some Chinese seller, I guess. And yeah, the sheet that they gave with this is obviously in Chinese, but I hope I don't need it. So there's the bill of materials here, and it should be easy enough, because there's all the markings here, and yeah, that should be straightforward even with the Chinese, I hope. But we'll see. And yeah, the brand on this sticker, the sticker will go here. This is the scale for the tuning scale. The brand is Sonic. Well, if you can figure out which company this is supposed to be. So it's extremely cheap. The case is very cheaply made. Let's see about the components. We'll have a look in a minute. This is FM and AM. I just wanted to have a FM or AM radio kit like I used to have as a kid, but this here, although it has quite a few components, I think it's mainly all done by this chip here. This is the tuner chip, I guess. This should be the amplifier chip. The 9088 should be some kind of FM AM tuning chip, I guess. And the 32822 should be some kind of amplifier, I guess. And all the other circuitry around that is probably just supporting. So yeah, it's not quite what I had in mind, because you can build FM and AM radios out of discrete components by themselves. So let's switch on the soldering iron already. Take our good solder here, and then we can sort the components and get started and see if this actually will output any kind of music or radio, and what quality it actually is, and what components they packed in here. Okay, so I pre-sorted all the components, and they're not that many. So here's a bunch of resistors, and they're tiny. I think they are definitely not quarter watt, maybe they're 1/8 watt or 1/16 watt power. And I'm gonna pick up my trusty component tester here. You already know that, because just to double check the values. Plus, for me it takes ages to decipher the colored rings. And then we have a ton of ceramic capacitors. They are marked, which is good, but I will also double check them, because they won't be the highest quality ones. So this says 683, I think. So, for example, let's test this one here right away, what it will say. And says 16 nanofarads. Okay. So probably it says 603, I guess, right? Oh, it says 683, I think. Let's take another one. Not sure how those markings work, but I guess the 4 is the exponent of the power, and this is 80. nanofarads. Well, maybe it's a different scheme, because this says 104 and 104 seems to be 80 nanofarads. But nevertheless, I think the bomb mentions the markings. If you take a look here, it has here the markings 104, etc. So we don't even need to know the exact value. But that's okay. And everything's clearly marked here as well. Then we have 4 electrolytics, probably of the cheapest kind that you can imagine. They are here, and this is 10 volts, supposedly 100 micros. Let's put it in as well. Let's put it in and give it a test. 100 micros it says, and it is 102. V loss 5.2%, ESR 1.5 ohm. So not great, not terrible, but there you have it. Then we have this Ferrite core antenna for AM reception. We have a variable resistor, I think, or is this... No, this is, I think, a variable capacitor. Or is it? Looks like one. Then this might be... Let's see. Can we look inside? Can we look inside? Is this the variable? Yeah, this feels like a variable resistor, I would assume. And this actually looks more like... But no, it can't be. It's too much. I don't know. Could this be capacitive plates? What does it say? No, it says kilo ohms, right? Or what? 10 kilo ohms. Yeah, this is the variable resistor, which also makes more sense because it has so many pins. So this must be the variable capacitor, I guess. And it's hard to come by these for radio purposes. Usually nowadays you only get trimmer capacitors, which are not good for radio kits because you can turn them only so often. And the old bulky capacitors for radios, they're not being made anymore. Today you do everything with variable resistors and capacitive diodes, variDACs or whatever they are called. And these 2 inductors here are for FM, I guess. So we need that. This is the radio receiver chip and this is the amplifier. And we have a little transistor, I guess. Let's see, what does it say? It's a, can we focus? TA7642. Well, whatever that is, never heard of that. So let's plop it in the transistor tester. After all, that's what it was made for. And what do we get? Part unknown or damaged. Well, that's no good. Let's retry it. Might as well be that it's damaged. Or it's something that it doesn't know. So, what do they say? So it's actually an integrated circuit, so that's probably why it doesn't detect it. It's IC3, so this is probably, what is it? Can you see that? Up here, 7642, that should be it, I guess. 3 pins, yeah. Probably an amplifier, op amp, whatever, I don't know. I can look it up. But we can start soldering now, and I will start with the resistors and then work my way up. Okay, one more thing before we start. The little 3-pin TO92 package is actually the AM receiver. I wouldn't have believed it. I would have assumed some kind of amplifier or transistor style thingy. But this small package actually contains this whole equivalent circuit. And it's a receiver for AM. That's pretty neat. So yeah, I don't know how it actually works, but this is probably the input from the antenna, I guess, and the other is supply and ground. So that's pretty neat, and I guess that you have to tune outside of this thing, so this is probably the input from the tuning circuit. But that's amazing. That's totally crazy that you can have an AM radio with one of these. Yeah, nice to know. Okay, so most of the components have been soldered on. The ferrite antenna, the LED and the variable capacitor, plus a couple of wires and the speaker still need to be in place. So it was pretty much straightforward. On the back side there's the one FM chip, which is SMD, and that wasn't too hard. I didn't do my best solder jobs. As you can see, there's still also flux residue, which doesn't matter. I probably won't be cleaning this off because it's such a cheap kit. But yeah, usually this is quite easy. You just solder one leg and then across the other. Then you just swipe with the flat tip or semi-flat tip. What do you call this? Let's clean this soldering iron with this shaped tip. Let's see, don't burn yourself. Okay, with this you can just swipe the solder away and flick it away if it's doing solder bridges. But I think we are good here. The camera doesn't show that very well. So here's the terminal for the positive speaker. Here's ground, speaker ground. Then we have the two attachments for the AM antenna, for the FM antenna, the potentiometer, the variable resistor, which is also fine. And this looks like the minus terminal perhaps for the battery, I guess. And this might be the plus terminal for the battery, I hope. Speaker. Well, I was hoping that this is positive speaker, but this is probably positive for the battery. So there's some things to be figured out. I'm gonna solder the last few components in. Okay, so I put some super glue on the antenna holder and the antenna itself. I'm not sure if it will work, but we'll see. Plus I soldered the first wires onto the speakers. When this is dried, we will continue soldering that to the back. Here are the connectors for the battery, and I already shoved in the first contacts for the battery compartment. The next one will come right over here. So the spring is on the lower side here, so it has to go on the upper side there. And there's also the terminal for the wire. I'm wondering if I should attach it first, but I don't think that would be wise, because this is actually pretty tight fit. So this will not go in easily. Very gently pressing down. Yeah, it does work, sort of, kind of. Let's see if the other side works better. That's equally tight fit. Ah, that's what I was fearing, it will bend. So this is not fun at all. I think we might be there already. Let's check it. What does it look like? Okay, I think we might have messed up, which is not optimal. So, but I thought this would fit in like this, because there's this rounded part, this rounded shape, and this has to go down there. So that should be okay, but this is obviously the cutout for the spring, right? But if we have it on this side here, then it doesn't make sense to have it on the other side. Well, either way, doesn't matter. Yeah, that's actually quite the puzzle. So I think, did they cut that out, or is it in the cast? I think it's cast like that. So the speaker will go in here, with the wires coming through there. Then it definitely looks like this is the cutout for the spring. But I'm wondering if I have to bend them over anyway. Might be. Let's find some tweezers, pincers, whatever you call them. Yeah, I'm gonna fiddle a bit with this. So after fiddling with this case, and for lack of better words, I gave up to put all this in there, because the quality of the case is pretty rubbish, to be honest. The holes don't align very well. Then I had the problem with the battery connector. The cables that they were supplying were too short to reach the battery connector. Maybe I'm doing something wrong, but it's really hard. Plus, the antenna is coated with chrome, nickel, I don't know. Definitely something which solder doesn't stick to. So you have to use the screw to screw in, basically to clamp the cable into place so that you have a connection. And I couldn't get this to happen in the case here, which is on this side here. You should be putting in the antenna. Plus the wheels have a lot of friction, especially due to the weird red indicator thingy here. And yeah, so all in all, this is extremely fiddly and not very pleasant to work with. So maybe we'll build some other box later to put this into. And yeah, other than that, it actually works, but for it to work nicely, we should actually put something behind the antenna wire. I'm gonna take a little bit of paper, because if the AM antenna wires come anywhere close to the FM stuff, you will get weird effects. So I guess just some, what do you call it, tape, sticky tape over there should do the trick. Scotch tape, I guess you call it. Yeah, and I wired up a different battery compartment. This one here, I've got a ton of these. I've got a ton of these connectors. They are just your basic 9-volt battery plugs, but you can use these containers. They come in sizes of 2AA or 4AA, or you can of course put a 9-volt battery in there as well. But this here runs off of 3 volts, so that's fine. And I would guess that it would also work with 4.5 volts or 3 rechargeables, which comes out to 3.6 volts. But I haven't tried that, so use it at your own risk. So if we turn this on, this is currently in the FM setting. We can already hear something. So tuning is a bit delicate, but it works. Yeah, here you have it. But it's very, very delicate. So if I touch this inductor here, it will basically switch around. So in order not to get any copyright strikes here, I hope, we're gonna switch to AM. And this is much harder to get something in here because I think all the German stations shut down a couple of years back. So with a bit of luck we might get something from the Netherlands or France or Belgium maybe. We get a lot of noise from all kinds of interference here probably. So I think it works, but the main problem might be that there are no more stations on the AM band here in Germany. But so here we are again with the classical music. And yeah, all in all I can say it definitely works. It has been an interesting experience to put this together. So the case is complete and utter garbage. The components are okay, I guess. The AM part is, yeah, I can't verify it. I would have to probably make my own AM transmitter or something to test that out. But it does work. It is not the greatest of kits, I must say. I wouldn't necessarily recommend it. Although you get quite a bunch of components. The bill of materials was not really necessary, but it's there because everything is also printed on the circuit board. So I was hoping to get a more basic thing without the ICs for the AM and the FM reception, and on the back side that they put the amplifier into an IC. I get that, but it's much more interesting to have all the different stages of an FM receiver spelled out in discrete components, or an AM receiver for that matter. And that would have been nice. And there are still shortwave radios out there transmitting stuff. So having the possibility to do that would also be nice. So this kit is not for that. If you just want to practice soldering a bit, you get a bunch of components for, I don't know, around 10 euros or something with a crappy case. The antenna can be probably reused for something else, the AM antenna as well. So maybe you just buy it for the components. Maybe even build this thing but put it in a completely different case. I think the variable capacitor can be used for a different radio as well. So yeah, for the components alone it's fine, especially since the capacitor can't be you can't get those anymore on Mauser or stuff, or at least I wasn't able to find something outside of trimmer capacitors. That's the only good thing to say about this. So it was interesting, but not recommended. Next up will be hopefully a bit more interesting kit, and the very next episodes will deal with more software stuff again. So if you like that, please hit the subscribe button, because then you will see new videos popping up in your feed, and hit the share and like buttons as well. And I hope to see you soon.